Good morning, students. Myself is Krishnandra Sahu from Bhuvananda School of Engineering, Kotak. Today I will discuss about control system engineering. So in this semester, control system engineering is a very important chapter. In the control system engineering, particularly, I discuss today class regarding the block diagram algebra in the control system. Okay. In control system engineering, block diagram is a method by which we represent a control system by different blocks for each element. Okay. So today class, the outlines are introduction of a control system and introduction of a block diagram. Then we discuss about basic elements of a block diagram representation of an electrical system, and the canonical form of a closed loop systems, and rules for block diagram reduction. Then some simple problems we will solve in today's class. Today first, what is the control system? A control system is a system which controls some parameters by the system with a suitable control element. So you see here is an example of a control system, an automatic electrical iron is there. In this electrical iron, you see this is the reference input, a thermostat is here, heating element here, sole pole iron here, and control output. And the thermostat acts as a controller, and the heating element acts as an actuator, and the sole plate of iron is a process. So this the bottom line, which is the feedback, which feedback means it compare always in each time it compare the output with the input. So thermostat is a device which sends the temperature from the output, and we compare if sometimes some high temperature required, so that gives signal to the heating element. So heating element becomes more heated. So this is the example of a control system. Here each element is represented by blocks. So that's why block is a very important point or important term in the control system engineering. Then introduction to block diagram. A block diagram is a diagram which is the combination of some elements represented by blocks. Each block must be contains the transfer function of that element. Next is the block diagram is a single block or a combination of blocks. Block diagram may be single blocks or sometimes a combination of many blocks. So these are used to represent a control system by the pictorial form. So block diagram is used for particularly to simplify a complex system, representation of a complex system. So a complete control system can be represented by a number of blocks with interconnected manner. So there is the application of a block diagram, how the block diagram is used in the field of electrical engineering. So particularly for hardware design circuit or electronic design circuit or software design circuit or process flow for diagrams. So when we represent such circuits, we take the help of a block diagram. So the next my topic is basic elements of a block diagram. So the basic elements of block diagram are block, summing point, and the take-up point. So three basic elements of a block diagram. Block diagram is a combination of three basic elements. One is a block, second is summing point, third is a take-up point. So now let us consider a block diagram where all the basic elements are details explained. So I see, so I consider a closed loop system here. This is a closed loop system. So this is a closed loop system is here. So in this closed loop system, it consists two blocks. This closed loop system consisting two blocks. One block which has the transfer function Gs, and second block which contains the transfer function Hs. So now this block contains the transfer function Gs and the second block which contains the transfer function Hs. So it consists of two blocks having transfer function Gs and Hs. Then also you see here there is one summing point, left hand side is a summing point, this is summing point here, and the right hand side is a take-off point. So next is the arrow mark indicates, the arrow mark is here, you see in the block diagram, the arrow mark is the flow of signals. The arrow mark indicates the flow of signals in the block diagram. Now let us discuss regarding each element, block, summing point, take-home point, one by one. So first to discuss about block here. You see block. Block may be represent a single element in a control system which contains particular system is contains many elements like the previous automatic electric iron. So there is thermostat, there is a heating element, there is sole plate. So each element can be represented by a single block, or also a block contains many elements. Sometimes many elements can also represented by a block. Next is the transfer function is the main component of a block. The block must contain the transfer function of that element. Next is block is a single line diagram. Okay, block, each block must be there is a single input, there must be at least single output there. Then you see the arrow mark indicate the flow of variables. Flow of variables from one block to other block is presented by a arrow sign. Next is the following figure show the block diagram having input is the x's here in this block diagram, a simple block diagram here. Here the x's the input here and output is the ys. X's means Laplace of xt. The time signal Laplace is equal to xs. So here ys is the Laplace of output signal yt. So gs is the transfer function here. So in each block, the diagram, the output and input are related by, you see here, in each block, the output ys and the input xs are related by the transfer function gs. Means you remember, so xs input signal into the block transformer value is equal to output signal. xs into gs is equal to ys. So I am discussing here, you see. So each block of a diagram, the output and input are related together by a transfer function, where the transfer function is given by gs is equal to ys by xs, or ys is equal to gs into xx. So gs means block transformer value, block transfer function value, xs the input signal. So input signal xs into transfer function value of the block is equal to output signal. Means ys is equal to gs into xs. So this implies what is the gs? The gs is equal to ys by xs. Ys means output signal by input signal. For a particular block, output signal by input signal is equal to transfer function of that block. So output of the block is obtained by, you see here, y is the output signal. So output of the block is obtained, you see in this block, this output ys is obtained by multiplying the input signal into the block transfer function value. In each block, the output signal is equal to the multiplication of input signal into the block transfer function value. That means in this picture, ys is equal to, here you see ys is equal to xs into gs. So if I just see here ys is equal to, you see the output signal ys, which is equal to input signal xs into block transfer function value gs. Output signal in every block, the output signal is equal to the multiplication of input signal into block transfer function value. Next is summing point. Summing point means, you see, summing point is required. It is also called as a error detector. Summing point. Summing point is represented by cross sign. I have told in the previous picture, you see in the previous picture here, this is the summing point. Summing, this one is the summing point. Summing point here you see. This point is a summing point. This one is a summing point. Summing point. So summing point is required when two signals are added or subtracted. When two signals are added or subtracted, we use a summing point. So now details discuss about the summing point. Here you see summing point of signals or difference of signals. Sum of signals or difference of signals is represented by using a summing point. Summing point also called the error detector. Summing point is represented by a cross sign. Summing point is represented by a cross sign. You see here the summing point is represented by cross sign. Summing point is always represented by a cross sign. So it has a two or more inputs. Each summing point has a two or more inputs and a single output. It produces the algebraic sum of inputs. It also performs the summation or subtraction of input based on the polarity of the inputs. Let us see the three operations of a summing point, different operations of a summing point I discuss here. So you see, this is a summing point here. This summing point is used for addition or summation of two signals, signal A, signal B. If two signals are added, supplying to a point, if two signals are required to add and supply to a point, we use a summing point A and B. A is a positive signal, B is a positive signal. So the output signal Y is equal to A plus B. That means if the notes here, the following are some two summing points, a summing point here. Summing point has the two signals, A signal, B signal. Okay, A signal is positive, B and also positive. A and B are both are positive. The summing point produces output Y, Y the sum of A plus B. So for two signals addition, we use a summing point. Here two signals, this summing point is represent for a summation of two signals. Another point, another example here. If a signal is a positive signal, other is negative signal, means A and B, two signals, we have to want two signals and subtracted. If two signals are subtracted, then we use this type of summing point. The which is the positive signal is a plus and which is negative signal, that is a minus. So signal A and the signal B both are put in a summing point and the output signal is A minus B, which is equal to A minus B. So Y is equal to A minus B, means Y output signal Y is equal to plus A signal and a minus B signal, which is equal to A minus B. Next, another example of a summing point you see. Here we take three signals are here. Three signals are you have to add and supply to a particular point. When three signals are adding and supplying to a particular point, we use this type of a summing point. A summing point A is a positive summing point, positive signal, B is a positive signal and C is a negative signal here. So both are added in this summing point. Summing point means it is also adder is here. Here added here, summing points are added. So signal A, signal B is positive, as signal C is negative. So hence in this picture, so what is the output? In this picture, the output Y is equal to A positive, B positive, C negative. So output signal is equal to sum of A plus B and subtraction of C. Means finally we conclude that summing point used in a block diagram where two or more signals are added and subtracted and supplied to a particular point. Two or more signals, if you want to supply a particular point, then we can use the summing point. Next is take-off point. The third basic element in the block diagram is take-off point. So your take-off point means when a single signal you apply two or more blocks. Single signal when apply two or more blocks, at that time we take the help of a summing point. A single signal, same signal, you have to apply two or more blocks or two or more places of a control system block diagram. You see, where one signal is applied to two or more blocks or summing points is represented by a take-off point. Take-off point is a point from which the same input signal can be passed through more than one branch. By take-off point, same signal we can supply more than one branch. That means with the help of a take-off point, you see, this take-off point is here. This is a take-off point. By the help of a take-off point, we can apply same input one or more blocks or summing point. So you see the picture of a take-off point is here. In this following figure, the take-off point is used for connecting the same input RS. You see here the same signal, a single signal RS, we apply three blocks. This block transfer function GAS, second block transfer GBS, third is GCS. The three elements are here. Block transfer function means the three blocks are representing three elements, means single supply, same signal RS, I have to apply in the three blocks. That's why I am using here take-off point. This space I am using a take-off point. This one is a take-off point. Take-off point means that is used for applying a single signal, same signal, three or more blocks or three or more summing points. So this is here, RS is two blocks is here, one block here, second block here, three block here. Same signal I have to apply in the three blocks. That's why I am using a summing point here. This is called a summing point here. Next to discuss here, in the example there, take-off point used in the connect, you see here also in this picture, this is a control loop system is here. Here both summing point is used, you see in this picture. This picture, this is a summing point. This is a block diagram or block. This is a block. This one is a block. BLO, CK block. This is a summing point. This one is summing point. Point. This is a block. This is a take-up point. This is take-up point here. So in this picture, this block diagram contains summing point, block, and a take-up point is here. So now discuss how you draw the block diagram, or means topic is block diagram represent of electrical system. Because in the field of electrical engineering, so many electrical systems are there. So electrical system, how you represent electrical system in form of block diagram. That is our topic. So means you remember, electrical system mainly contains three basic elements. One is resistor, inductor, and a capacitor. Okay, that means any electrical circuit must be combination of a resistor, inductor, capacitor, or the sources, voltage source or current source is there. So means electrical circuit is given. How you draw the block diagram? You see, block diagram representation of electrical system. Consider a series RLC circuit. I am considering here a RLC series circuit. You see here, this is RLC series circuit. I consider here. This is RLC series circuit. This is RLC series circuit is here. So in the top picture you see that is a RLC series circuit, which is in time domain. So I have to draw the block diagram of this RLC series circuit. A block RLC series circuit re mate block diagram काटिबाको पड़िबो. केमिता block diagram काटिबी? So I draw the block diagram by using the methods. The methods means you see, first if this RLC circuit is given, so you see, consider a RLC series circuit in the following figure, where input signal, what is the input voltage? VIT. What is the output voltage? V0t. Input and output voltage are VIT and V0t are here. So let IT is the current passing through the circuit. So this figure is the time domain circuit. This picture is given the time domain circuit. So to finding the block diagram, you remember, if circuit is given time domain, you have to apply Laplace transformation. So Laplace transformation method you apply in time domain circuit and you find the S domain circuit, a Laplace circuit. So see, here is a time domain circuit. By applying Laplace transformation, by applying the Laplace transformation to this circuit, I will get the S domain circuit. This circuit is a S domain circuit. This circuit is a S domain circuit. Time domain थिबो ताको हम Laplace transform apply करिके हम बाहर करिबा S domain circuit. This is a S domain circuit is here. So in the S domain circuit, you find some current equation, voltage equation. You determine some equation, current equation, voltage equation from this S domain circuit. S domain circuit रे हमें current equation बाहर करिबा, voltage equation बाहर करिबा, माने किछ relation equation बाहर करिबा. So equation बा relation को use करिके हमें block diagram काटिबा. So see, so this figure you see in this figure. So in this figure you apply KVL, you apply the Kirchhoff's voltage law in this figure. So see, I apply KVL here. Let this point is a positive point. This point is a positive point. This point is a negative point here. Okay. If I apply KVL, what is the equation? This is equal to VIS plus VS minus RIS. S domain also apply KVL and KCL, similar like time domain circuit. So KVL, KCL also apply in the S domain circuit, like also in the time domain circuit. You see, so resistor, so drop is minus RIS minus SL IS, inductor we drop. Then minus voltage how much here? Here the voltage is equal to how much? V0S plus to minus. So it is minus drop is here is equal to 0. If you simplify, VIS minus V0S is equal to how much? So you minus take right hand side. So it's equal to RIS plus SLIS. Okay. So if you take common IS, so IS becomes, you see here IS is equal to VIS minus V naught S by R plus SL. So see, this is a current equation. this current equation, a Laplace equation, current equation you get from here. Second equation you can find, so you see, so V naught is equal to V naught S, voltage across the capacitor is equal to current in the capacitor, Is into 1 by SC. So you see, so when in the time domain circuit you convert into S domain circuit, Laplace circuit, for VIT, which is time form, function of time, convert into function of S. Okay, because you know that Laplace of Ft, time domain is equal to how much? Fs. Small letter f, Laplace kale capital letter hi jaye, t becomes s. So that's why is the VIT, small v achi, t achi, tak Laplace ka dalala small capital VIS, it becomes s form. Similarly, I means I of t. This I in the time domain I of t, tak Laplace ka dale is hi gala. Resistor Laplace, for resistor Laplace is R here. But inductor L ka Laplace is equal to Ls or SL. So V0t, so output voltage Laplace is equal to V0s, capacitor Laplace is equal to 1 by Cs or 1 by Sc. So here the input current in the circuit is equal to IT, loop current. Laplace is equal to Is here. Okay, so that is the important point here. Means a time domain circuit is given, you convert into Laplace circuit or Laplace domain circuit, then apply the Kirchhoff's voltage law or Kirchhoff's current law to find the equations, S domain equations, Laplace equations. Okay, so I got here two equations, two relations here. This is equation 1, which is also, these two equations are also written in the next page. If I go to the next page, you see these equations. This is one current equation I am getting here. One current equation. This is one current equation I am getting here. One current equation. Okay. And this is the voltage equation you get here. On a voltage equation here. So using this current equation and voltage equation, you see, let us now draw for these two equations. So what are the first equation I am getting? First equation is, first equation here, VIS minus V0S by